Welcome to our live webcast, Cybersecurity for Control Systems and Discrete Automations. Thank you for joining us. My name is Jacob, and I will be the operator for the presentation today. Before we get started, I would like to take a moment to acquaint you with a few features of this web event technology. At any time, you may adjust your audio using any computer volume settings that you may have. During this presentation, you will see a multiple-choice polling questions throughout the event. To participate in the polls, please select the buttons to the left of the answer that best represent your views or experiences. On the right-hand side of the screen, you will see a text chat window. There is a large window which holds all of your sent messages and a smaller text box at the bottom where you'll type in your questions. To send a question, click in the text box and type your text, and when finished, click the send button. All of the questions you submit are only seen by today's presenters, and your questions will be responded to in the order in which they were received and will be addressed at the end of the presentation. You will also be able to ask questions via telephone at the end of the presentation. At the conclusion of today's program, we ask that you complete a brief post-event survey. Please take a moment to complete this survey as it will help ISA plan future web events. We are joined today by our speakers, Eric Cosman and Robert Thompson, Product and Solution Security Officer. Eric Cosman is a chemical engineer, 35-plus years of experience in industrial information technology, including system design, selection, and architecture definition. He also has 15-plus years in ICS Cybersecurity at the company sector, national, and international level. Former leader, chemical sector Cybersecurity program. He's also a founding member and co-chair of the ISA99 committee, responsible for ISA 62443. He's also past vice president of standards and practices and executive board member at ISA. Robert Thompson has 10-plus years of experience in the automation field. He is active in all areas from factory automation to process automation regarding the security needs of customers, addressing a wide range of topics ranging from secure remote access, industrial security monitoring, endpoint protection, and IEC 62443 assessments. He also has responsibility in product and solution security officer for Siemens Plant Security Services, which ranges from risk analysis, vulnerability handling, as well as security trainings. Robert also in 2015, today, Siemens AG Plant Security Services, endpoint protection, automation firewall, industrial security monitoring, ISC 62443 assessments, as well as various security events. At this time, I would like to turn the microphone over to Eric to go ahead and begin the presentation. Eric?
Yes, hello, welcome everybody. Welcome to our webinar today. This first slide gives you an idea of what the flow of the general webinar and how it's going to, the topics we'll be covering. To get us started, I'm going to give an overview of the world we live in. That's topic number 3 on this agenda. I'm not quite sure the number. It seems to have gotten mixed up a little bit. But we'll start with item number 3, the world we live in, and then pick up with item 4. At item 4, I'll move it over to Robert, who will talk about the Siemens Solutions overview. And then item 5, we come back to specific solutions. And standards and practices, which shows up here as item number 1, actually should be down below specific solutions, I believe. So the order of these is a little bit mixed up, but these are the topics that we're going to cover. I'm not quite sure how the order gets fixed up, but we'll get that corrected later. So moving on to the next slide. For the next few minutes, I'm going to give you sort of a bird's eye view of the world we live in. And depending on your background and your experience, you probably have heard much of this. You may have heard much of this before, but hopefully there'll be a few new nuggets of information that you can take away. This is just my perspective on the situation we find ourselves in with regard to industrial control system security, and it's based on my experience having worked in this area for, as my introduction said, at least the last 15 years. So first of all, let's take a look at, in general, where we sit as of today. Risk, of course, continues to evolve, and the little icons at the right here is sort of the typical response to this. It's one of dismay, I guess, and a little bit of trepidation. People worry about the risk as it continues to evolve, and are they keeping up to date with and aware of the risks that they face. At the same time, sort of exacerbating this situation is the fact that complexity is also increasing. It seems like, we constantly are adding capability and functionality to control systems, and as that gets layered onto existing systems or even new systems get installed, they become more complex. On the plus side, or maybe under the heading of the jury's still out, standards are improving and new standards are becoming available. As a matter of fact, I just heard yesterday about a development in the standards area, and I'll touch on that a little bit later in the presentation. And then lastly, I think, which is definitely a piece of good news, practices based on those standards are becoming available. So more and more people are being encouraged to share their experiences in the form of practices in various venues, and people can use those practices, sometimes developed within their specific industry sectors, to get practical guidance as to what they should be taking on next. You probably have all seen a slide similar to this one here on slide 8. You've probably seen figures like this in the past. This goes back some 30 plus years to the days of, if you've been in this business as long as I have, you can remember the days of single computers, single PCs. And the biggest problem that we had to worry about were things like password guessing and simple viruses. Although the viruses might have been a challenge back then, we see them now as pretty simple and easy to deal with. But unfortunately, as time has gone on, the level of intruder knowledge has increased, as has the attack sophistication. And you can see as this line progresses, the complexity and sophistication of the tools has increased consistently through that time as well. And the security folks have, had to respond to that on a regular basis. So most recently, for example, at the upper right of the screen, we see ransomware, which is a very hot topic right now. And then, of course, we also have staged attacks, and in some cases, very targeted, specific attacks at industrial facilities. At the same time, the targets themselves have evolved over that same time frame. So as you can see at the far left, we used to have individual computers, typically PCs, but that has become more complex as the systems have become more complex, and computers got networked together, first of all, and then tied into corporate systems, and then finally industrial systems have become more interconnected, and we have the world today where pretty much everything is connected. So we have what's referred to as ubiquitous connectivity. That's a boon in terms of functionality, because everything can talk to everything else, and of course everything can talk to the internet pretty much. But it is also a significant challenge, because that connectivity brings with it complexity that makes mitigation, prevention, and response that much more complicated. So let's take for a moment to look at the risk, dig into the risk situation just a little bit more in more detail. Generally accepted that risk is a function of several parameters. It's listed here as a combination of likelihood, threat, vulnerability, and consequence. We can pretty much accept the fact, I believe, I hope you would agree, that likelihood increases with every successful attack or every successful incident. And the reason for that is those incidents get some publicity, and even if it's not the specific incident, the emergence of a particular attack usually gets into the news in some form. And the population out there, the great population on the internet, sees that, and of course there's a certain amount of copycatting going on and sharing of code and sharing of attacks. So the likelihood increases. Basically, people see that there's some benefit to an attack, and they try to get in on the action. At the same time, or as a result of that, the threats, as I mentioned earlier, are evolving and getting more sophisticated. In response to more sophisticated defense, the attacks and threats get more sophisticated as well. And then, of course, vulnerabilities are always with us. To my knowledge, and I've been in this business for a very long time, I'm not aware of anybody who has ever successfully written error-free code, totally error-free code. And so with errors introduced into the software, and in some cases, as we've seen most recently with the the news about Intel and AMD chips, sometimes those errors actually get into the hardware design. The vulnerabilities are there, and there are people out there who spend a great deal of their time hunting for these vulnerabilities, and several major suppliers actually have so-called bug bounties where they pay people to discover vulnerabilities. And then, of course, if you're an asset owner, and I have no way of knowing how many of you on the line are asset owners, but you're very familiar with this, is that in your industries, there are potentially very serious consequences. It could be equipment damage, it could be loss of production capability, it could be loss of reputation, product quality, and the list goes on. So all of these things come together to calculate your risk. And in the light of all of this, or at the same time, even though moving on here to slide number 11, even though we have all of this going on and a tremendous amount of publicity and coverage of these incidents, we have a certain number of what I call lingering myths that still are maybe not prevalent, but certainly common in our industry. The first, and I've grouped these into three categories. The first one is what I call denial. And people will say, well, nobody would want to attack us. I'm a small assembly plant in a small town in wherever, and why would anyone want to attack me? I'm not a big target. And of course, we know that even though if you are not the specific target of an attack, you could be a victim of so-called collateral damage, even just by virtue of the fact that you're using common technology. So that's a myth that you really can't rely on. The second one is it can't happen to us, which is sort of a variation of the first one. Believe me, it can happen to you. It does happen to people, even though they may think that they're rather inconspicuous in the overall scheme of things. The second category is what I call diversion, where people try to divert or defer the responsibility to someone else. And of course, the most common one of these is it's an IT problem, let them worry about it. But the problem with that and the debunking of that myth is going back to that interconnectivity comments that I was making earlier. If you're connected to those systems, and most importantly, if you're using common technology, be it operating systems or network platforms or devices, you are going to be subject to the same potential threats and vulnerabilities. So you really can't ignore this. And then lastly, there's a certain amount of naivete associated with this. People tend to think of security very often when they first get involved in this, the security response as a project. And so they will frame it as a project, structure the response as a project, which begs the question, when am I done? And of course, you're never done. Security is not a project, it's a lifestyle. And it's something that you're going to have to do in perpetuity. There's also a naive assumption that you can eliminate all vulnerabilities. I've already addressed that two comments ago. And then we've already talked about the fact that security incidents do, in fact, impact operations. Challenges, of course, there are many, many challenges. I'm not going to go through all of these, but you could read them on your own. I think you can resonate with some of these. Of course, perhaps the seminal challenge is design with no security. We have out there a tremendously large install base of technology, much of which goes back years or decades, that may or may not have been, and most likely probably was not, designed with security in mind. And so in that case, all you have to do is, or what you have to do, I should say, is add external mitigations and layers on top to protect it. There are other challenges, and as I said, and I'll just pick a few to highlight here. In industrial control systems, it's often difficult, if not impossible, to test systems because they're always in production. You may have a 24/7 operation, and if you don't have the resources to have a dedicated test bed, then testing can be a very real challenge. And at the same time, the counter version of that is that, or the equivalent to that is that you also don't have the time to take systems down to perform maintenance, like updates and virus updates and software patching and so forth. So as you can see, and I think if you're involved in this space, you'll understand most of these challenges. risks, of course, as I mentioned earlier, continue to evolve. And the first of these, even though it's not maybe a threat-directed risk, is the people relying on this so-called security by obscurity. People have traditionally thought, well, control systems are so arcane and difficult and complex, sometimes we don't even understand them, so how could an attacker understand them? And I think events in recent years have pretty much debunked that feeling. There are people out there studying control systems, buying systems off of eBay in order to understand how they work, and control systems are definitely a viable target now. And again, I'll just pick a couple of things here. Weak configuration, default or weak configuration, not taking advantage of the capability of the system and basically just turning it on and running it as is. Perhaps one of the most challenging ones is the lack of accountability, and this goes back to the comment that I made earlier about let IT worry about it. If nobody's, if everybody's accountable, nobody's accountable. And if nobody's accountable, then things don't get done. So it's very important to assign specific accountability for tasks and have a process in place to ensure that accountability is followed. So how does all of this fit together? What are the drivers and what are the responses for the antecedents, for example? We know that technology is evolving rapidly. It's constantly changing, and there's no sign of that stopping. So whether it's mobility, or whether it's industrial internet, or whether it's cloud computing, and all of the things that keep coming to the fore, those technology developments in turn drive new capability in products and solutions, in control system architectures, for example. They become more dynamic, they become more distributed, and most importantly, from a security perspective, they become more reliant on external components and systems. And as a result of that, we end up with a greatly increased attack surface. That's a security term for basically all of the different areas of penetration or possibilities of penetration, and an increased likelihood of attack and a loss of control, perhaps, if you're not watching this and managing it, of the cybersecurity risk. So summing all of this up, you can see that this is a complicated environment, and the ubiquitous connectivity that I mentioned earlier is at the heart of this complexity. Everything is connected to everything else. And, be that the traditional enterprise to factory connection on the vertical dimension here from top to bottom, but now we have smart devices, intelligent assets, both remote and local, and all of these other things that we have to worry about. So the ecosystem can be quite complicated. Sometimes it's a challenge to even characterize it. So speaking of characterization, one view of the market, because as we all know, there's a growing and thriving market of solutions and mitigating factors out there. The ARC Advisory Group, which you may or may not be familiar with, which is a consulting and research company based here in the U.S., has divided this market into 5 general categories. And as you can see them here, anomaly and breach detection, endpoint protection, management solutions, network security, and services. And then those can be further grouped into 2 broad categories of products and services. This is just a way of helping people understand when suppliers come to them and talk to them and say, I've got this latest and greatest thing that you should be looking at. Try to help them put it into a bucket, if you will, one of 5 categories as to what kind of a solution that is. Because very often what happens is individual solutions get purchased over time, and after a certain period of time, asset owners find that they have an overlap in the capabilities, and they've effectively spent more money than they had to. So that brings us, that's a very broad overview of the industry as we see it, and as I said, much of this is probably not new to you, but hopefully you picked up a few tidbits along the way. And this brings us to our first poll question. So I'll turn it back to Jacob to run the poll.
Perfect. Thank you very much. As you said, the first polling question here, do you have sufficient knowledge for the evolving situation? Yes. Yes, but more information is needed. Not sure of what works best, or not at all. We'll give just a few seconds for everyone to go ahead and go ahead and give their answer. Again, just click on the button to the left of the answer that best represents your views. All right, thank you very much. We'll go ahead and end the poll. We'll go ahead and leave the results up for Eric.
Yeah, I'm encouraged by the poll results. If you look at this, basically it's 70% have responded either yes or yes, but more information is needed, and so that's very encouraging. It tells me two things. It tells me that this audience is very aware of the challenges that they face, and also the fact that 44% of you have said that more information is needed tells me that you are open to learning more, because as we know, this is a rapidly changing area, and we can never say that none of us, no matter how long we've been in this space, can say, well, we have everything we need and we don't have to learn anything new. A large part of our discretionary time has to be spent in educating ourselves and learning and following new developments as they occur. So that's all very encouraging. So I think with that, we'll move on to the next section, and I'll turn it over to Robert, who's going to give us an overview of some of the solutions available from Siemens.
Thank you, Eric. Good morning, everybody, or afternoon, wherever you may be in the world. Today, what I'd like to do is give you a little bit of an overview of some of the options that you would have, some of the solutions that Siemens is able to offer you. Basically, where did we come from? Siemens has developed, in cooperation with other countries and different entities, a concept based on what we like to call defense in depth. So if we look at defense in depth, we can see that it's basically built upon plant security, network security, as well as system integrity. So with a combination of these three different rings, we have products that we can place in different areas which build upon each other to give you a better protection. So think of it sort of like an onion. The more you peel away from the onion, the smaller it gets. So to get to the center of the onion, you have to go through all the different layers to get there. So we've developed a service portfolio based on three major categories: assess security, implement security, and manage security. And what this is based on is that the assess security is the first step. We need to evaluate the security status of an industrial plant or industrial location. So what we find is a lot of the times is that the customer knows they need to do something as far as security goes, but they're not really sure what they need to do or where they should start or what their actual status is at the moment. So this is where we would come in and provide you with some more information. If we look at implement security, here we can help you by reducing the risk implementing different security measures. This is also something we find a lot of times with the industrial environment, is that you don't have dedicated IT guys working there. So it's a lot of times that your engineer, he's great with his software, his programming, its HMIs, all of that type of thing, but he's not really familiar with security and how to implement it. So we can help you here. And the next one is for our customers that say, I know I need something, but I don't have the manpower, I don't know how to implement it, I don't want to be bothered managing it. Can you do it for us? And this is where we can also offer you a managed solution. So for you, it would be simple, a black box that's doing what it's supposed to do. So if we look at the different categories, we'll start with assess security. What's the main goals? To analyze the threats and vulnerabilities, identify the risks, and recommend security measures. So we have three different assessments that we offer to customers. The first one is the IEC 62443, which is becoming now more and more worldwide the automation standard for assessments. And this is based off of ISA99 and ISO 27001 to a certain degree. There are multiple parts to these assessments. For the normal automation production area, we're using the chapter 3.3 and 2.1. We also offer a ISO 27001 gap assessment. This is the full-blown ISO 27001. And we also offer a risk and vulnerability assessment. This is a little bit different compared to the other two. This isn't just a simple question and answer gap assessment. This is a deep dive on site. So this is where we would actually go in, look at your network configuration, talk to your employees, see how everything's connected, go through and look at your different cabinets. Are they locked? How are the devices configured? This type of thing. If we look at implement security, what can we offer you for implementation? Security policy consulting. This is very important, especially for you OEMs or machine builders, or for the end customers who has to deal with OEMs or machine builders, to have a security policy in place of what you're expecting from new machines and what you're expecting from your production area in general. We can also offer you a network security consulting, network design security. Maybe your plant needs a new network rework. You have everything in one IP band, no network segmentation, something of this nature. We can evaluate your network design and give you tips and hints on how we can improve this. Another one that we can offer is a cell protection and perimeter network, a zone configuration with the demilitarized zone or a perimeter network, using firewalls that we have on offer from our automation firewall to our automation firewall next generation, which will include deep packet inspection, NATing, networking, DMZs. As we can see here, we have firewalls for all areas of the production between the office network and the operations networking. We can offer you demilitarized zones so we can have your internet access for your pattern update servers and things of this nature. We also offer antivirus installation based on McAfee virus scan that's been very well received from our customers over the last 3 or 4 years, as well as patch management, due to the fact that 90% of all successful attacks found their way through with vulnerabilities that weren't patched already. One prime example, as Eric had mentioned earlier, was WannaCry. There was a patch out for quite a while before WannaCry came out, but most of the machines that were targeted or actually affected were not patched. Another interesting fact is only 2% of all systems are fully patched. Now, this has different reasons for this. One could be simply that you don't have a maintenance window on a regular basis to apply patches, but there are solutions around that as well. And I'll be showing you one of those later. We also offer patch management implementation references or ideas. As we can see here, this is a prime example of a process automation plant where most everything is running redundant. You can also see here that we roll it out in different stages. And the reason for this is in case there is a patch that would cause a problem, it's not going to take down your whole production line. So this brings us to my first poll question, and I'll turn this over to Jacob.
Perfect, thank you. Next polling question here. Do you have a successful program for implementing Windows patches on your production systems? Yes, patches are applied regularly. Yes, patches are applied but not regularly. No, I am not aware patches are applied. And no, what is patch management? We'll give just a few seconds to answer this polling question. Answers are starting to slow down, so I'll go ahead and turn it back over to Robert with the results.
All right. This is actually kind of surprising to me. We have here 39, well, basically a pretty even split, 40-40, between yes, patches are applied regularly, yes, patches are applied but not regularly. That's generally not what we're finding in the automation. we find quite a few, most of the time, that systems aren't patched on a regular basis. So this is actually very encouraging. I think the 18% is probably here. They're just not sure what the company policy might be as far as applying patches. So this is actually very encouraging what I'm seeing here. It's not normally what we see. Just put it that way. Okay, I think that takes care of that. So then we start talking a little bit about our managed security policy, portfolio. Why did we decide to do a managed security portfolio? We saw that there are growing vulnerabilities. Security incidents have been estimated at 51% in all German companies. 51% of all companies have been in some kind of vulnerability. Annual losses to the German economy is 51 billion euros. Please, since I work in Germany with Siemens, this is why I use these type of numbers. But 51 billion euros is quite a bit for a country the size of Germany. Time taken to discover a security incident is approximately anywhere from 98 to 200 days. So with this number being said, think about somebody having access to your system from anywhere from 98 to 200 days before they've been noticed. It's a long time. A lot can happen. Unknown causes of penetration, roughly 28%. There's no identification of how they've gotten in, what they've taken, what methods they use to get there. So Siemens has developed a cyber emergency readiness team for our customer side. This is something that we've been using for quite a while within Siemens itself, but this is also something we can now offer our end customers. So if you would have some kind of security event at your factory or at your production, we would be able to help you determine what happened. We also offer a continuous end-to-end point solution. So this could be something like a security management system with remote incident handling, a global threat intelligent database. This may be locally installed at your factory. Industrial security monitoring is something also that we offer. We can take all of those log files that you're gathering from different devices, from your different PCs in the system. We can evaluate all those log files also for automation devices and tell you exactly what's going on. And some of the things that we can determine with that, some of the typical monitoring scenarios that we have would be here, for example, spread of malware, new network devices that are connected to your system, brute force or suspicious user activities, changes to configurations, prohibited or suspicious network connections, network and port scans, USB devices. These are things that we can identify and notify you about within minutes of these things happening. Something else that we offer is a security vulnerabilities functionality. I'm sure a lot of you have multiple components, different manufacturers, different software versions running. How do you keep track of all the security updates? Is there somebody responsible for doing that for you? With an app that we have now running over our MindSphere platform, we can tell you exactly for your hardware and your software when a new vulnerability has been found and corrected. So how does it work is basically we have a database that covers all kinds of more than 25,000 components in the monitoring system, from software to hardware. We connect this to a list of components that you supply us, and whenever a new vulnerability is found or detected, it's forwarded to you over a web interface where you can see exactly what has to be addressed. So this is my second poll question. have you implemented any kind of whitelisting or endpoint protection in your production environment? There's 4 options here. Yes, no, whitelisting is important, but we need more information. No, I'm concerned whitelisting will break my production system. No, we have not implemented whitelisting. What is whitelisting? Okay, I think it's pretty much down to a stop, Jacob. Okay, so what do we have here? We have a fairly decent split between yes and no. Yes, 31% of you say that you are using some kind of whitelisting or solution. And we have another 34% that are saying no, whitelisting is important, but we need more information. And I'm concerned whitelisting will break my production system. Okay, there's always a few concerns. And 20% don't even know what whitelisting is. So I think this is something I will be addressing a little bit later in the presentation. So I hope everybody sticks around to see a live demo of the whitelisting software. So I think this is where it goes back over to Eric and a little bit more information about standards and practices. Eric?
Yes, thank you, Robert. And before I start this section, I just do want to pick up a theme, I guess, from Robert's comments, and it's to give kudos to Siemens and virtually all of the major control system vendors. I think we've seen, those of us that have been in this industry for quite a while, that the awareness of the challenges and the threats that we face has increased dramatically. And clearly the suppliers have risen to that challenge. They have developed improved standards, practices, and services to as part of that increased awareness and passed on that awareness to their customers. Segue into my comments here on standards and practices, I also want to give them credit where credit is due to where they've contributed considerable expertise to the development of standards, international standards, and associated practices. Virtually all of the control system suppliers, including Siemens, are actively involved in furthering the standards in this space, and that involves a considerable commitment of time, effort, and expertise. And I believe they all deserve credit for that. So let's move on. I'll give you an overview of where we stand today with standards, including some recent breaking information that I alluded to earlier. First of all, let's talk about ISA99 and ISA or IEC 62443. There's some confusion around the nomenclature and terminology used here. ISA99 is the committee that is operated by ISA as part of the Standards and Practices Department. It was formed in 2002 to address standards for industrial cybersecurity and has been operating ever since. As I mentioned in my introduction, I co-chair that committee. The products of that committee are labeled with the 62443 number. ISA decided to adopt the 62443 number, which was assigned by IEC, in order to emphasize the fact that these standards, as they are developed by ISA, are simultaneously submitted for approval to both ISA processes and then accredited as ANSI national standards in the United States, as well as international IEC standards. So the two groups working on this, I'd mentioned the ISA99 committee, and in addition to that, we have a strong liaison relationship and sort of a co-development relationship with Technical Committee 65 Working Group 10 in IEC. So both of those result in the 62443. They work together to develop the 62443 standards that are then branded as either ISA, ANSI-ISA, or IEC standards. A given standard is identical between IEC and ISA. The only thing that's different is the label that's given to it and some of the boilerplate at the beginning of the document. We also work closely with the Joint Technical Committee 1 SC27 in ISO that is responsible for the ISO 27000 series, including 27001. We have a liaison with them as well. And that's important to note because people often ask, is it, should we look at ISO 27001 or should we look at IEC 62443? And the answer is both. IEC 62443 is designed purposely not to duplicate 27001, but to complement it. As we know, 27001 is a general purpose IT standard, and 62443 basically adopts the practices from that where they apply, interprets them for the particular context, and then augments them or improves them to make them more applicable in an industrial environment. So I hope that clears up any confusion that people may have about how the standards are related. If you look at the 62443 standards, we talk about 62443 as a singular noun, but in fact the standards, it is a suite of standards and technical reports, of which there are 13, soon to be 14 parts, each addressing a specific aspect of the problem. This diagram shows you how those parts are organized. We have 4 tiers, the first of which at the top are addressed at sort of the general audience, and the purpose of these is to establish the fundamental concepts and foundational requirements upon which the rest of the more focused standards are based. And then as we move down to the second tier, the one that you see here in green, the documents in this series are aimed primarily at the asset owner or the end user. So they address things like how to design and implement your cybersecurity management system, how to address patch management, and then the fourth one on the right, 2-4, is focused primarily at asset owners and system integrators and how they cooperate to actually implement these systems in a secure manner. The bottom 2 tiers talk about the actual products and technologies, the control systems that are used. First, at the system level, which is at level 3, where we talk about things like, what are the basic system level requirements, and then there's a specific one, 3-2, which is security risk assessment and system design. So how from a system level perspective do you do a risk assessment? This standard is not fully or formally released yet, but it has been approved by it's been approved by ISA and it's currently in ballot for IEC, and we expect those ballot results to come back in the next month or two. And then at the lower level, the 4 series address specific requirements for components and the development of said components. So 4-1 lays out requirements for system and component suppliers and talks about the need for a secure development life cycle and how to assess those life cycles against a specific set of requirements. And 4-2 talks about more detailed technical requirements at the component level. Now, I've teased you a couple of times with a recent development that just occurred, I just heard about yesterday, and that's with regard to the 4-1 standard. That standard has now been approved by both ISA and IEC PC65 Working Group 10, and will soon be available. And this is one that the suppliers are going to want to take a good look at, because this is the one, as I mentioned, that lays out for them what the expectations and the normative requirements are for an effective security development lifecycle and the processes that they use to develop the systems and components. This is where we start to address that secure by design imperative. Make sure that systems are as secure as possible as they're designed, developed, sold, and deployed. So that gives you a sort of a quick overview of the 62443 series. As you can see, there are a lot of pieces. I mentioned the 14th part. There is a document that's being circulated for comment right now that talks about a concept called protection levels. And basically, the protection level concept is the intersection of maturity levels and security levels. So it addresses the question of how do I assess my current level of security given or in the context of the maturity of my program. And that, as I said, that document's available for review and will eventually find its way out as an additional normative standard. So while most of my effort, of course, as you've seen, has been focused on the 62443 series through the ISA99 committee, I would be remiss if I didn't mention that there are several other standards that are available depending on the industry that you're in. For example, in the energy sector, particularly in the U.S., the North American Electric Reliability Council, I think is what NERC stands for, has their STIP standards, which a lot of people have used because they speak very much to the response to regulatory requirements. We've already talked about the ISO 27000 series. NIST, which is, although it's a U.S. organization, it's a department within the United States government, National Institute of Standards and Technology, has a couple of what they call special publications, SB 853, which is general purpose IT security, and more specific for this group, 882, which is industrial control system security. Even though these are U.S. publications, there's nothing U.S. specific in them. So I would encourage people to at least take a look at them as supporting reference material. And I will mention that the 882 document, we have an active liaison between NIST and ISA99 to make sure that that document and the 62443 series are not in conflict or do not diverge in terms of their requirements and recommendations. And then lastly, the one I'll mention is one that's fairly recent. UL, formerly Underwriters Labs, which is an organization here in the U.S., has a set of standards called 2900, designated 2900, that talks about security or addresses security of primarily individual devices. So those are also valuable references that if you're not aware of, you may want to check out. So let's take a look at standards. Regardless of what standards we're talking about, what does the standards landscape look like? You can see standards are maturing as fast as we possibly can, given the time and process involved in developing consensus-based standards, are maturing to, I believe, almost what I call feature complete. And I put that term in quotes. What do I mean by that? Well, it's basically that all of the essential elements of an effective security response have been or soon will be addressed. But on the other hand, standards, and this is another term that I use and why I put it in quotes as a colloquialism, is they're not really intended to be used by civilians. And what I mean by that, I don't mean that in a disparaging way or as a derogatory term. I'm simply saying that reading standards can be pretty daunting. The 62443 series altogether is approaching 1,000 pages of material. And so asset owners simply don't have the time and the resources very often to devote to becoming experts in this space. And this is why it's important to work with partners and suppliers and service providers to help understand the nuances of these standards and how they apply to your situation. Helping with that is the emergence of practices as opposed to standards. And practices can be in areas such as system or device assessment. Robert talked about some of what Siemens offers in this area. They can also provide guidance on what to adopt, how to adopt it, how to apply it in your specific area. And then what we're trying to encourage in the community is more sharing of results in the form of case studies or use cases so that we can share from each other. And of course, incident information is a delicate one. People don't always want to share the details of an incident or may be prevented from doing so for a variety of reasons, legal reasons and others. But to the extent that we can, we should be trying to share maybe what I would call sanitized information that people can benefit from. And that's happening in a variety of conferences and other venues and events. Some of you may be familiar with the F4 conference, which is a major technical conference in this space. It's occurring next week in Miami. The ARC advisory group that I referred to earlier has a forum coming up in February. There are events that take place virtually all over the world, in the Middle East and Europe, North America, Pacific, that address the topic and help people share their perspectives and insights. I put this slide in here. I'm not going to spend a lot of time on it, but I just put it in for a couple of reasons. The NIST Cybersecurity Framework, which is not a standard, but is as the term implies, a framework or a context in which to apply all of this guidance, gives valuable information and useful guidance on how to construct an effective response to the cybersecurity risks that we face. And they break it into identify, protect, detect, respond, and recover. As I said, we certainly don't have the time to go into this in detail, but if you are not familiar with the NIST framework, I would encourage you to take a look at it. And the framework has recently been updated and is out for public comment. So if you have seen that, I would encourage you to take a look at it and the changes, submit comments. And if you haven't seen it, you feel free to contact me, either today or after the webinar, and I'd be happy to give you additional information. There are other sources of help as well. We are a community, the industrial automation community, and we should work with each other and help each other, both within companies and across companies. But within the company, within your individual company, the first place I would encourage people to take advantage of, if you have not done so already, is the partnership between your IT and your OT organization, your operation organization. Build that partnership, foster that partnership, because you do have a great deal in common and you can learn from each other. There are many case studies that show that although this sometimes may be difficult for various internal cultural reasons, it's well worth doing. External bodies, if you're in a regulated industry or even in an industry that regulates itself, there are expectations and regulations that you should be aware of. I mentioned standards and frameworks already, so those are available, and practices and guidance. So it's sometimes a challenge to stay on top of all of this and filter separate the so-called wheat from the chaff, but it's well worth the exercise. And then lastly, and certainly by no means least, there are a variety of companies, whether they're control system companies, suppliers, like control system suppliers, or independent service companies that have purchased or contract services that can help you meet this challenge. So the point here is to move from the theoretical to the practical. And what do I mean by that? As asset owners, and I was an asset owner, worked for an asset owner for many years, so I know the challenges very well. We have to have, first of all, effective asset management. You have to know what you have in your control systems environment. If you can't identify it, you certainly can't secure it. So asset management, for a variety of reasons, investment planning, life cycle management, ties directly into security management. As part of identifying, or once you've identified those assets, you'll no doubt find some that are obsolete or unpatchable, or for a variety of reasons can't be touched. They might be in a regulated process, and the changes simply can't be made without a lot of difficulty. So you have to find ways to mitigate the risks of those by some sort of layered on security. Blocking of unverified applications. This is a reference or a nod to the whitelisting that Robert is going to be talking about in a few minutes. This is a very promising emerging technology, or rapidly developing technology, and if used correctly can be very effective, but like any tool, it has to be used correctly and wisely. And then finally, integrating your security management and your automation management. And so, what do I mean by that? Well, what I really mean is engaging all of the stakeholders, even down to the plant operators, if you have operators in your plant or factory. Some do and some don't. But make sure that everybody is involved and understands their responsibilities and what's expected of them. And then integrating that into how you manage your automation system throughout its life cycle. So that brings us to the fourth poll question, I think fourth and final poll question, and this goes directly to the question of the security management system. Do you participate or contribute to an active industrial control system cybersecurity management program? So I'll turn it back to Jacob.
Yeah, the options here are yes, a leader, Yes, a contributor. No, we are planning a program, or no current plans. Again, you can just click on the button to the left of the answer that best represents your views. We'll give it just a minute to go ahead and let those results come in. It looks like results are starting to slow down a little bit. I'll go and turn it back over to Eric.
Okay, thank you. So this one is a bit of a mixed bag, I guess. The encouraging part of the results here is that over 50% are either responded that they either are leading such a program or are contributing to a program. So of course that implies that such a program does exist and is in place. That's very encouraging. I think that if we had taken such a poll even 3 or 4 years ago, that number would probably have been significantly lower. On the other side of the coin, we have over a quarter of the people that said that they have no current plans. And I guess I would encourage those that responded to this to do everything that you possibly can to encourage or promote the need for such a program. As I hope you've gotten from my remarks, this is a group responsibility, or this is a collective responsibility, and the only really effective way that I'm aware of to adequately address all aspects of the problem is to bring everyone to the table, to use a common metaphor, and get their thoughts, their ideas, their perspectives, as opposed to some sort of centrally mandated program out of IT or even a central engineering function. That kind of approach, in my experience, has much lower probability of success. So the more that you can encourage collaboration and getting everybody's views on both what has to be done as well as what can practically be done, the more likely you are to be successful. So with that, I think we'll move on to the next section, I think the last section, and Robert is going to talk specifically about whitelisting technology.
Thank you, Eric. So what I'd like to do with this next chapter is I'd like to talk to you a little bit about the differences between whitelisting and antivirus. I'm sure most of everybody here is aware that antivirus, you need some kind of internet connection because you're always in need of pattern updates for it to be effective. So this is always causes some problems in the production line when you're saying in the production area you shouldn't be having internet connections. So let's take a quick look at whitelisting and some of the challenges and drivers. Ransomware infected via emails and vulnerabilities with emails. It's a big common one. WannaCry was sent around with the email. There are over 100 known ransomware versions with encryption functions that we know of right now. Other targeted attacks are expected, and 32% of companies that were attacked by ransomware were infected. So what we're seeing here is that there's always more and more coming as far as email attacks or ransomware attacks, these type of things that are coming in over email, and most likely that's something that you have to click on. So here are some concrete threats to industrial controllers. One of the big ones is discontinued operating systems, Windows XP. I will bet almost everybody in this meeting has at least one Windows XP system still running, if not older. Windows 7 is already scheduled for phase out. Then we have social engineering, phishing emails, remote access. These types of things can all cause problems with your systems. So whitelisting isn't the solution to everything, but the difference is whitelisting, how does it work? Whitelisting scans your computer for executable files. So any kind of file that can be executed, a DLL, a batch, a bin file, an exe file, anything that I can actually physically execute is scanned, receives a hash code and is entered into a list. And then the system's locked down. So what happens if a virus is on your computer? Say, for example, a colleague from work brings a USB stick from home, which isn't uncommon, and there's a virus on it. The virus, as we can see here in image number 1, is on the machine. We can see it here in this with this little logo down here. If I can get my mouse back up here, we can see here that we have a virus on the machine. The virus tries to execute. The virus hash code is checked within its listing, and once this hash code is not available, it's blocked from running. And this is something I'll be showing you in a few minutes using a live demonstration. So there are, of course, some pros and cons to whitelisting. One of the big disadvantages of whitelisting is that the machine modifications, for example, updates or the installation of new software, require a little bit more consideration when installing or during the initial preparation of the machine. There has to be some thought given into it. So it is a little bit more complicated than just inserting a CD and clicking install. The big factor or the big pro for whitelisting is that you need no internet connection. All of the files are stored locally on the machine. You have a very low use of computer resources. As with virus malware protection, there's often quite a high use of memory and CPU. This is not the case with whitelisting. And it lets you extend your time period of when you need to install those types of Windows patches or security patches. Because even if there is something out there, such as a ransomware or a malware that's executable, it cannot run. So now we'll be going into a live demo of the whitelisting software. If we can just pull up that other screen. I will have here for you. So we see here I have a Windows XP machine running. I hope everybody can see that Windows XP. And I also have a Windows Server 2012 R2 running. This is what's called the ePolicy Orchestrator from McAfee, and this is a centralized management system recommended for any kind of environment running with 10 or more clients. This gives you an actual graphic interface to the different clients. We'll let you know what's going on and what's running. We can see here in this top corner that I have one active system. I have one current status, which is 100%. This is just my one machine. And this one machine is a demo XP machine. So here I see over the top 10 pending policy discovery requests, we have here a total of 6, and this is a test.bat file that I installed after the installation. And here we have the machine itself and the number of incidents over the last 7 days. We see here we have 3 incidents. So if I will go back to my demo machine, I'll just go ahead and minimize this. Here I have that test.bat file that I mentioned earlier, and I'm just going to go ahead and run this real quick. And we'll see right away that we have a message on the bottom: application and change control is not a corporate whitelist and will not be allowed to run. So the question comes back to, okay, it blocked the software from running, but how do I know that it's even been running, or somebody tried to execute it? If I go back here and I send my events to my EPO, unfortunately I have to do this because it's actually designed to refresh every 5 minutes. If I go back here to my centralized managed system, my graphic interface, I can see here on the bottom I've increased to 4. And if I click on this machine, I see here on the 11th of January at 3:05 p.m. Central European Time exactly what's happened. The user AUD user, execution denied. It was a command.exe file from documents and settings, desktop test.bat. So even if the user on the other side, on that XP client, would delete all the files, all the entries, I would still have an overview of what's going on with this machine in close to real time. So another thing that happens quite a bit is when a virus is installed on a computer, it likes to delete files or it likes to rename files. So if I go in here to a typical Windows, here to Windows, and I'm going to go here to Windows System 32, and I'm going to find myself a DLL file, atmlib.dll. If I try to delete this, it looks like it's going to come up, confirm file, delete. I'm going to go ahead and click yes right away. Within a couple of milliseconds, I get my warning that it's been blocked, and I also get this error block. A hacker wouldn't be able to delete this. A user can always say, okay, you know what? I tried something. I tried to install a program in the late shift, maybe in the night shift. I'm bored. I want to play solitaire or whatever. I don't want anybody to know. So they think it's gone. But if I go, I'm just going to go ahead and refresh that while I'm doing this. If I go to my Windows Event Viewer, I also see it right here. The 1st of January, 2018, process ID 1164, which user tried to delete the ADMI lib library. So even if the customer thinks that he's gotten rid of it, or the user thinks he's got rid of the warning, it's still in the event viewer. So I'm not going to sit here and tell you that whitelisting or application control is the all-in-one solution. There is no silver bullet. But it does add a great deal of protection to your PC operating systems, even your legacy systems. This software will run anywhere from Windows NT up to Windows 10. Some Linux systems, depending upon the kernel, will also run. So you can see all of these legacy systems that are still out there running because you can't update due to the fact that there's no new hardware, there's no firmware, there's no new software. You have to stay with the system. You can continue to run these systems in a fairly secure and safe way. So if we go back now to the EPO server, go back to that dashboard again, we should see that it's increased again. And if we look down here, again we see the DLL file. So again, all of those two things that I've tried to delete. Another big one that people like to do is rename things. So if I go down here, I look for, I'm just going to try to rename this DLL. Rename. No, it's also preventing me from renaming. So with this software, it's very straightforward. It's fairly easy to implement. You don't need a PhD or a master's degree to do it. And this is also something that we can offer you from Siemens for those legacy systems, or even the new systems coming into the factory that you want to lock down for any number of different reasons. That ends the live demo. One last thing I have for you. I get this question quite a bit. I'm kind of new to security. I really don't know where I'm at the moment. Do I need an assessment? Do I need a firewall? Do I need this or that? What Siemens has done is we've created a industrial security health check. This is a free to use online health check. You can go online, answer roughly 12 to 15 questions, and within a couple of seconds, you have a rough overview based on our defense in depth strategy, plant security, network security, and system integrity, where you are at the moment. This isn't a cure-all or a solution for an assessment. This just gives you a rough idea to let you know, okay, I'm not very well off. I need to do this, or I need to do a little bit more. And, of course, there's also contact information there that you can contact us directly. So that pretty much wraps up my presentation. And I think now that I've finished my presentation, and Eric as well, that we'll try to answer some of your questions.
All right, perfect. Thank you very much. Just a few things real quick before we start taking any questions. Just a reminder, the Q&A is located on the right-hand side of your screen. To submit a question, type your question into the small text box at the bottom, and when finished, click the send button. Real quick, Eric, did you have anything before we go ahead and jump into questions?
Yeah, I just wanted to mention that to Robert and others, as Robert's been speaking, I've gone through the questions that we've queued up and assigned them to either Robert or myself. I apologize. I think the first question that was posed, I might have inadvertently deleted it. So if whoever posed that question doesn't hear your question addressed, you can either repost it or contact us after the webinar.
We can definitely go ahead and retrieve that question real quick. I'll go ahead and do that while we're taking a few of these other ones here.
Okay.
Like I said, we do have a number of questions. First question here, this one is for Eric. What is the difference between ISO 27001 and 27002?
Yeah, good question. And I'm not an ISO 27000 expert, but the 27000 series includes several standards. The 27001 is the so-called formative or base standard in the series, and it sort of covers the landscape of IT security, in a broad sense. And then the subsequent parts of the standards, the 27000 series, goes into the various more detailed aspects, very similar to the approach that we've used with 6443. And I believe, and Robert may correct me if I'm wrong, if he knows, that the 27002 specifically addresses the construction and the design, construction, and organization of a cybersecurity management system.
All right, perfect. Wait, go ahead.
I just replying to Eric that I believe his definition of the 27002 is correct.
All right, and I do have that retrieved question here. On slide 10, go ahead and get over to slide 10 real quick. Question is, could you add a bullet? Let's go ahead and get there. Could you also add a bullet? Tempo is increasing. Have in mind that 2017 was a year when revelations of malware seemed to come one after the other. In May, we heard of WannaCry, then not Petya. By midsummer, we heard of Crash Override. Then December, we heard of Triton. And just a week ago, we heard of Spectre. The question is, will the defenders be able to keep up with this? Even before last year, we seemed to be 2 steps behind. What are the implications of the defenders not being able to keep up?
Yeah, it's an excellent question, and I suspect that we probably all have our own perspectives on an answer, but the observation is certainly valid, and that is that the rate of these things is increasing as the awareness rises. So that's a good news, bad news story. More people are paying attention and looking at their systems. Suppliers, for example, even including hardware suppliers with this sector and these related things that affect things at the chip level. But the result of that increased vigilance is the emergence of more vulnerabilities. Now, I think it's important to distinguish between vulnerabilities and actual threats. The vulnerabilities may or may not lead to immediate threat, but having said that, it does not excuse us or provide us any relief in the sense that when vulnerabilities are identified, we at least have to do some sort of an assessment. And if you're like my former company, when I was involved in this space as an asset owner, these major vulnerabilities trigger an activity of a bunch of people scurrying around trying to formulate a response to management as to, just exactly how exposed are we, and irrespective of whether or not we actually see a real threat, what are we doing to prepare ourselves? I can't give you unfortunately can't give you a good response on how we're going to deal with this as an industry, but I will go back to the comments that I made about helping each other and sharing and making sure that you take maximum advantage of the services available to you, the services and assistance available to you, ranging from simple collaboration with your peers, which is, other than your effort, is free, all the way to the other extreme, which is where you actually outsource or purchase managed services. If you don't have the wherewithal to do it yourself, you may be able to find a way of actually hiring somebody to do it for you. It's not a good answer, but it's the best I can offer at this point.
All right.
I don't know if you have some thoughts on that.
No, I think you pretty much hit everything, all the major points. It's a
Okay,
collaboration
thanks.
thing. It's going to be purely based on what's working for one person will work for somebody else, and finding a happy middle. I don't think this is a situation that's going away anytime soon.
No, not at all.
Question here. This one has been relevant to slide 26. Before you come to a site with your 3 layers of security, shouldn't the customer first have done their homework and answered the questions, what needs to be protected, from what threats, and the customer answers those 2 questions, then comes to your proposals on answering the 3rd question, how to protect chosen assets from determined threats in the most cost-effective way?
That's a very good, important aspect. Before we do any kind of assessment, there's always some kind of customer contact ahead of time. If the customer is interested in a security assessment, for example, say an IEC 62443, the first step would be is that the customer gets in contact to a Siemens representative in his area. And usually they contact us in headquarters in Germany, and we then contact the customer together over a live meeting or a Skype call, something of that nature, and ask specific questions. Can you provide us with a network plan? Can you provide us with a data flow chart? Can you provide us with all kinds of different documentation that before we even go to the customer site, we know how the customer's network is set up, if he's doing network segmentation, if he has firewalls, where the firewalls are placed, how the switching is configured. So these are all kinds of prep work that we do before we even go to the customer site. The problem is that what we find when we go to the customer site is that most of the time they don't know all of their hardware assets. They don't understand that there's a wireless access point somewhere in their system because they've upgraded systems 10 years ago. And it was just placed in there real quick, and nobody actually manages or takes care of it. So those are kind of typical things that we see. Again, we do offer the security health check that you can go ahead and give yourself a pre-self-assessment, I guess you could call it, and then decide for yourself if that's something that you need to look into a little bit further. And when we finish the assessment, it's not that we just come in and tell you all the bad things that you've done or all the bad situations. We also let you know the good things that you've done, the things that are set up right, and you receive a report at the end that you can use with management to try to get those funds to increase your security, because that's usually where the problem lays, is that the production line doesn't have the funds to do what they need to do. And this is with a full-blown assessment report with diagrams, with graphs and charts and everything in it, so you can take it to management and say, listen, this is what we found that needs to be corrected. What are we going to do? And what we'll find is a lot of times low-hanging fruit. It'll be simple things that you can do on your own, assigning the correct subnet mask in your network, maybe correcting a couple of firewall policies, installing a whitelisting solution or an antivirus solution. So it's not all things that are going to cost you a lot of money or a lot of time. A lot of it's just you're taking your time to do it right, or maybe reconfiguring something.
All right, perfect.
This is Eric. If I could make an additional comment on that real quick.
Of course.
And I don't offer this as an alternative or a competitor or competition to what Robert is describing from Siemens, but there is a tool that you may or may not be aware of, depending on your background and how much research you've done, there is a tool called CSET, C-S-E-T, Charlie, Sam, Edward, Thomas, that's available for free from it was developed by the U.S. Department of Homeland Security, but it could be used anywhere. There's nothing U.S. specific about it. And you can download this tool and burn it to a CD, and it basically takes you through a like a very detailed questionnaire, probably much more comprehensive and time-consuming than Robert is talking about. And it does something very similar, and then produces a report of sort of research or reference sources that you might want to look at and steps that you may want to take. Now, I recommend this with some hesitancy because I don't know if it's been updated recently, but it's something that you might want to at least investigate.
All right. Our next question here. What are the steps to be taken to improve the patch management rate? I think this one's for Eric.
Yeah, I'm sure Robert has thoughts on this too, but I assigned it to myself just so I can get some initial thoughts in here. The detailed question or the specific answer to this question, of course, varies very much by according to your particular circumstance. For example, if you're able to deal with parts of your system independently or somewhat independently Robert mentioned redundancy. If you have redundancy built into your system, in some cases it's possible to take systems offline, individual parts offline and patch them and then roll them back, or roll them out and roll them back into production. If you don't have that capability, and even if you do, I would strongly recommend, obviously, testing patches in some sort of test lab so that you have a higher probability of success and higher confidence level in the patches. As far as increasing the rate, the more we can automate, the better. Now, the downside of automation is, you don't want it too automated because the ultimate automation is just push the patches as soon as they're available, and nobody wants to do that because nobody has enough confidence in the impact of the patch. So for each individual situation, you're going to have to come up with the right balance between automation and push versus implementation and pull. I will go back just as a reference to the one of the documents in the 62443 series, 2-3, specifically addresses patch management. It's currently available as a technical report, but it's in the process of being elevated to a normative standard, and it lays out a very systematic approach to industrial system patch management, including how to integrate patch sources or patches that have sourced from a variety of places, like if you have multiple suppliers, and how to plan the implementation of those patches. So if you haven't taken a look at that document, I would encourage you to do so. It's not the only such reference available, but it's one that I'm most familiar with, and it was actually developed by a team led by a gentleman who worked for 3M, which is a large manufacturer that you probably know. And so it's based on a lot of good, solid, practical experience. The co-chair of that group, by the way, was an employee of Siemens, or is an employee of Siemens. So it's a perfect example of a technical report and practice that was developed jointly and cooperatively between end users and suppliers.
Yeah, my point of view on it is that it's a tough situation. It depends completely upon what your manufacturing systems look like. If you are a Siemens component user or Siemens software user, we do test security patches before or shortly after they're released, and if we find a patch that does cause problems, we let you know. So this is something that Siemens is already doing for you. If you're using Siemens components and software, then that's an advantage there. If you're not, and you do need to have some kind of testing environment, it again goes back to using something else as a countermeasure, such as a whitelisting solution. So if for some reason you do have some kind of vulnerability that's been patched, you can prevent a malware from being run. One prime example of that is that the application controller, the whitelisting software from McAfee, did block WannaCry for customers that were already using it. So that was some positive feedback that we've gotten recently as far as the whitelisting software goes. So again, I think it's really independent upon each individual production area and your particular situation.
Thank you. Next question here. If only 2% of systems are only ever patched, can we count on this as an adequate defense? Do you offer patch management for level 2 systems as a service?
I guess you would have to determine what a level 2 system is. Siemens in general will take care of, we do offer patch management. This is also something that we do offer, but we only go to a certain degree. We will not go into the office network. But if you have, say, for example, an MES system or a IT system specifically for the production area, yes, we will cover that system also.
Yeah, and I believe that is generally what we think of as level 2. MES is level 3, Enterprise is level 4. Assuming the levels that they're talking about are the reference model from the Purdue reference model, which is reflected in both ISA95 and ISA99.
There's maybe another question relevant to the last one, maybe just an add-on to that last part. It says 98 to 200 days time to discover. Is that a stat for level 2?
That's a stat general. That goes all the way up to the office network. I would suggest that it's probably even higher on the production networks, for the simple reason is that you don't have that IT infrastructure normally in the background running their daily checks and log files being verified and so on. But this basically goes to any system not using some kind of monitoring system. So if you're hosting in your office network a file share that's not being monitored, somebody could be in there for anywhere from 98 to 200 days.
Yeah, I can give you a practical example. This is a real example of sort of your worst case, maybe not worst case, but the scenario that you probably wouldn't want to have happen to you is where the detection, the first awareness of being penetrated came not from inside the company, but from outside the company, in this case, law enforcement. And this is a real example of a U.S.-based company that the first indication that they have had that they were penetrated was a phone call from the FBI. And they had been penetrated sometime before, I don't remember the exact number of days, but this is a so-called advanced persistent threat, if you're familiar with the APT term. And the response to that, to finally get to a point where they were confident that the attacker had been expelled from the system was, probably, I'm going to guess, at least 6 months, because of the complexity of the systems and the time it took to search and root out all of those vestiges of the attack. Get rid of them. So it's a pretty scary statistic.
Good time for one more question here. You mentioned that you can support McAfee on XP. How long can you guarantee DAT updates for the XP environment?
As far as XP goes, our support for XP would be with whitelisting. So that would be a McAfee application control solution, and Siemens has a contract with McAfee that runs over multiple years. So I don't think there's a major problem here due to the fact that the McAfee software itself, once it's set up, doesn't need any kind of updates.
All right, perfect. Well, that is all the time we have for questions. Did either one of you have any other final thoughts before we go ahead and wrap up?
The only thing I would like to say from my side, if there are any questions that we didn't get to, my contact information is here in the slides. There's also an additional email address in the slide set for Siemens. Please feel free to contact myself or my colleagues, and we'll try to get you any kind of information you need, any kind of resources, slide sets, or information, and we'll get in contact with you as soon as humanly possible.
Yeah, for me, I guess I don't really have any specifics other than to echo what Robert said. If there's anything I can do, I'm happy to do so. I am an independent consultant on the business side, and this is my volunteer work for the ISA99 committee. So I'm somewhat limited in my resources, but I'll do the best I can. And the only other thing, I guess, the last thing I would leave you with is this theme of outreach and collaboration. If you have are presented with an opportunity to collaborate and share with your counterparts in your industry or even beyond your industry segment, please do everything you possibly can to do so, because this is a problem that we all share and we're all going to have to work on solving.
All right, well, perfect. Thank you to you both for the presentation, and thank you for taking all the questions. On behalf of ISA, I would like to thank you for your participation in today's event. If you missed any portion of this webinar or would like to rewatch the recorded version, we will be emailing all registrants a link to the recording along with additional links for supporting information. A post-event survey will appear requesting your feedback. Please take a moment to complete the survey, as will help ISA plan future web events. This does conclude today's program. Thank you, and have a great day.